So let's look at another example involving Cartesian products. So if I take the Cartesian product, R cross R, so remember R represents the real numbers. This is the set of all points in the Euclidean plane, right, which is our two-dimensional space, if you want to think about it like that. Right, X and Y, all of the points in the plane here, that would be that Cartesian product, R cross R. Now, if we just took a line in that space, so for example, the graph of the straight line, y equals 2x plus 3 is the set xy in R cross R, where y equals 2x plus 3. So this line is really a subset of this Cartesian product. So now I want to look at taking some intervals for my set. So let's look at the following example. Let's say A is going to be the interval 0 to 1. So just remember that this is the set of all x and r, where x is between 0 and 1, but it could be equal to 0, not equal to 1. Let's take for our second interval B the numbers between 2 and 3, including 2, or sorry, not including 2, but including 3. So maybe I'll use a Y here, use a different letter. And then what I want to do is take the cross product of these two. So A cross B would contain the set of all points in R cross R, where x is between 0 and 1, including 0, not including 1, and y is between 2 and 3, not including 2, but including 3. And so what's nice when you're working with intervals is that I can represent this Cartesian product geometrically. So let's try to represent this geometrically. I'm looking for the set of all points whose x-coordinate is between 0 and 1. I do want to include 0, but I don't want to include 1. And then y needs to be between 2 and 3, not including 2, but I am including 3. And so in the end, what you're going to get is this rectangular region of points. Y isn't allowed to be 2. X isn't allowed to be 1. But y is allowed to be 3. X is allowed to be 1. So you're getting this rectangular region, but you're not including 2 of the sides. So these 2 sides here, they're not included. That's why I did a dotted line. but the other two sides are included. I guess there'd be like an open circle. So let me kind of clean this up a little bit. This corner point is not included, and neither is this corner point here. And there's my region geometrically here. And the last thing I want to talk about in this video will be, let's go back now. Let's go back to an earlier example. Remember when we had the set A was x, y, and our set B was the set 1, 2, 3. If I ask how many elements are in A, you would tell me 2. How many elements are in B? There are 3. And if you look back at our previous example, you would see that how many elements did we find in A cross B? There were 6. And the 6 is a product of these two numbers, 2 and 3, and that turns out to be true in general. So for all finite sets A and B, A cross B, the number of elements in A cross B, it's the number of elements in A times the number of elements in my set B.